Welcome. Today, we're diving into Kotlin's control flow and function features. Kotlin is known for its expressive syntax and modern approach to programming. We'll explore how if, when, and for loops work, and see why Kotlin's control flow is both powerful and concise. We'll also break down functions, including lambdas, high-order functions, and more. Whether you're new to Kotlin or looking to deepen your understanding, this guide will help you write cleaner, more efficient code. Let's start by understanding the basics of control flow in Kotlin. Kotlin, the if statement, is more than just a conditional check. It's an expression. This means it can return a value directly, making your code more concise. For example, you can assign the result of an if expression to a variable, replacing the need for a ternary operator, which Kotlin doesn't have. This approach not only makes your code shorter, but also easier to read. Let's see how this works in practice and why it's a favorite among Kotlin developers. Consider this example. You have a score variable, and you want to determine if it's a pass or fail. In Kotlin, you can write val result equals if score greater or equal 50, pass else fail. This single line replaces the traditional if-else block and the ternary operator found in other languages. When you print result, you'll get either pass or fail based on the score. This makes your code both compact and expressive, reducing boilerplate and potential errors. Kotlin's for loop is designed to be simple and flexible. You can iterate over any collection, array, or range that provides an iterator. For example, you can loop through a range of numbers using for I in 1, 3, which will print 1, 2, and 3. This syntax is clean and avoids the need for manual index management. Whether you're working with lists, arrays, or custom collections, the for loop in Kotlin makes iterations straightforward and readable. When expression in Kotlin is a powerful alternative to the traditional switch statement found in Java and other languages. Unlike switch, when is an expression, meaning it can return a value, its syntax is cleaner and more flexible, allowing you to match multiple values, ranges, types, and even complex expressions. This makes your code more readable and less error-prone, especially when handling multiple conditions. Kotlin's when expression offers several advantages over Java's switch statement. First, you don't need break statements when automatically stops after a matching branch, preventing fall-through bugs. You can also check multiple values in a single branch, use ranges, and even match types or expressions. Smart casting is another benefit. If you check an object's type, Kotlin automatically casts it for you. These features make when safer and more versatile. Let's look at a practical example. Suppose you have a function that processes different types of input. Using when, you can match single values, multiple values, ranges, and even types. For instance, when x, 1, 2, 3 in 10, 20 is string, this flexibility allows you to handle complex logic in a clean and readable way, all within a single expression. While loop in Kotlin works just like in Java or C++, it checks the condition before executing the loop body. If the condition is true, the body runs. If not, the loop exits. This means the loop might not run at all if the condition is false from the start. It's perfect for situations where you need to repeat an action as long as a certain condition holds true. Do-while loop is similar to the while loop, but with one key difference. It always executes the loop body at least once before checking the condition. This is useful when you need to ensure that the code inside the loop runs at least once, regardless of the condition. After the first execution, the loop continues as long as the condition remains true. Here's an example to clarify the difference. Suppose you have a variable set to 5. A while loop will print as long as it's greater than 3, so you'll see 5 and 4. A do-while loop, on the other hand, will always print its message at least once, even if the condition is false from the start. This distinction is important when you need at least one guaranteed execution. Now that we've covered control flow, let's move on to functions in Kotlin. Functions are the building blocks of any program, and Kotlin offers several advanced features to make your code more modular and expressive. We look at lambda functions, high-order functions, default and named arguments, inline functions, local functions, vararg parameters, and infix notation. Each of these features helps you write cleaner and more efficient code. Lambda function, or lambda expression, is an anonymous function in Kotlin. Unlike regular functions, you don't declare it with the fun keyword. Instead, you define it directly as an expression, usually inside curly braces. Lambdas are great for short, one-off pieces of logic, like passing a function as an argument or transforming a collection. If your lambda has only one parameter, you can use the implicit name it for simplicity. See a lambda in action. Suppose you want to sum two numbers. You can write val sum equals a int b, int a plus b. This lambda takes two integers and returns their sum. You can also use lambdas with collections. For example, numbers.map it2 doubles each number in the list. This concise syntax makes your code more readable and expressive. High-order function is a function that takes another function as a parameter, returns a function, or does both. This is a key feature of functional programming in Kotlin. High-order functions let you write more flexible and reusable code by abstracting common patterns and behaviors. They're widely used in Kotlin's standard library, especially for collection operations like map, filter, and reduce. Here's an example of a higher-order function. Suppose you have a function called calculate that takes an integer and another function as parameters. You can pass a lambda to calculate, such as it, to compute the square of a number. This pattern allows you to pass different operations to the same function, making your code more modular and reusable. Kotlin allows you to define default values for function parameters. This means that if the caller skips an argument, the default value is used. Default arguments make your functions more flexible and reduce the need for overloaded methods. You can provide sensible defaults for most parameters, making function calls simpler and less error-prone. Named arguments let you specify which parameter you're passing a value to by name. This removes ambiguity, especially when a function has multiple parameters of the same type. You can also pass arguments out of order, as long as you use their names. This feature makes your code more readable and less prone to mistakes. Let's look at an example. Suppose you have a greet function with parameters for name, message, and punctuation, each with default values. You can call greet Alice to use all defaults or greet Bob good morning to override just the message. You can also call greet punctuation name equals Charlie to specify arguments by name and out of order. This flexibility makes your code much clearer. You use high-order functions. Kotlin creates an object for the function parameter, which adds a small runtime overhead. By marking a function as inline, you tell the compiler to copy the function's code directly into the call site. This eliminates the overhead, making your code faster. However, use inline only for small functions that take lambdas, as inlining large functions can increase your binary size. Here's an example of an inline function. Suppose you have a function called executeTask that takes a lambda as a parameter. By marking it inline, the compiler copies the code of executeTask and the lambda directly into the main function. This reduces runtime overhead and can improve performance, especially in performance-critical code. Kotlin allows you to define functions inside other functions, called local functions. This is useful for encapsulating logic that only makes sense within a specific context. Local functions can access variables from the outer function, helping you organize your code and avoid duplication. They're a great way to keep your code clean and focused. Imagine you have a function that validates a user's input. You can define a local function called checkNotEmpty inside your main function to check if a value is empty. This local function can access the parameters of the outer function, making your validation logic more organized and less repetitive. It's a simple way to keep related code together. The vararg modifier in Kotlin lets you pass a variable number of arguments to a function. Inside the function, the vararg parameter behaves like an array. This is useful when you don't know how many arguments you'll need to handle. You can also use the spread operator to pass an existing array into a vararg parameter. Suppose you have a function called printAllAllies that takes a vararg of names. You can call printAllAllies, hero, mage, rogue to pass individual items, or use printAllAllies, *extra allies to pass an array. This flexibility makes your functions more adaptable and easier to use in different scenarios. Kotlin supports infix notation, allowing you to call certain functions without dots or parentheses. To use infix notation, the function must be a member or extension function, have exactly one parameter, and not accept vararg or default values. Infix notation makes your code read more like natural language, improving readability. Here's an example of infix notation. Suppose you define an extension function onto for the string class. You can call it using either the traditional syntax, laptop, onto, Alex, or the infix syntax, laptop, onto Alex. The infix version reads like clean English prose, making your code more expressive and easier to understand. Recap: Kotlin's control flow structures, if, when, for, while, and do while, offer expressive and concise ways to manage your program's logic. The if and when expressions stand out for their ability to return values directly, reducing boilerplate and making your code more readable. Loops are straightforward and flexible, supporting a variety of use cases. Kotlin's function features lambdas, high-order functions, default and named arguments, inline functions, local functions, vararg parameters, and infix notation give you powerful tools to write clean, modular, and efficient code. These features help you avoid repetition, improve readability, and make your programs easier to maintain. Real-world Kotlin projects, you'll often use if and when expressions to handle decision-making. For example, you might use if to check user input or when to process different types of commands. Their expressive syntax helps you write logic that's both clear and concise, reducing the chance of errors and making your intentions obvious. Loops are essential for processing collections, handling user input, or performing repeated actions. In Kotlin, for loops are perfect for iterating over lists and ranges, while and do-while loops are ideal for scenarios where the number of iterations isn't known in advance. Their familiar syntax makes them easy to use for developers coming from other languages. Lambdas are widely used in Kotlin for collection operations, event handling, and callbacks. For example, you can use map, filter, and reduce with lambdas to transform data efficiently. Their concise syntax makes functional programming patterns easy to implement, helping you write code that's both powerful and readable. High-order functions are the backbone of many Kotlin libraries and frameworks. They let you pass behavior as parameters, making your code more flexible and reusable. You'll find high-order functions everywhere in Kotlin, from standard library functions like run and apply to custom utilities in your own projects. Default and named arguments are especially useful in APIs and library design. They let you provide sensible defaults while allowing callers to override only the parameters they need. This makes your functions easier to use and less error-prone, especially as the number of parameters grows. Inline functions are valuable in performance-critical code, such as custom collection operations or DSLs. By eliminating the overhead of function objects, inline functions help you write efficient code without sacrificing readability. Just remember to use them judiciously to avoid increasing your binary size unnecessarily. Local functions are great for organizing complex logic within a single function. For example, you might use a local function to validate input or perform a calculation that's only relevant in one place. This keeps your code modular and prevents unnecessary exposure of helper functions. Vararg parameters are perfect for functions that need to handle an unknown number of arguments, such as logging utilities, aggregators, or formatting functions. They make your APIs more flexible and user-friendly, allowing callers to pass as many arguments as needed without extra boilerplate. Infix notation shines in DSLs and APIs where readability is key. For example, you might define infix functions for building queries or configuring objects. This makes your code read like natural language, improving clarity and making it easier for others to understand your intent. One common mistake with when expressions is forgetting the else branch. If none of the branches match and there's no else, your code may not handle all possible cases, leading to bugs. Always include an else branch to cover unexpected input and ensure your code is robust. While inline functions can improve performance, overusing them can make your compiled binary much larger. Only mark small, lambda-accepting functions as inline. Avoid inlining large or complex functions, as this can lead to code bloat and longer compile times. Using vararg parameters, remember that you can only have one vararg in a function's parameter list. If you need to pass an array to vararg, use the spread operator *. Forgetting this can lead to confusing errors, so keep it in mind when designing flexible APIs. Fix functions must meet strict requirements. They must be member or extension functions, have exactly one parameter, and not accept vararg or default values. If you miss any of these, your function won't work with infix notation. Always double-check your function signature. Write clean Kotlin code, prefer expressions over statements when possible. Use if and when as expressions to assign values directly. Keep your branches concise and avoid deeply nested logic. This makes your code easier to read, maintain, and test. Designing functions, use default and named arguments to make your APIs flexible. Leverage lambdas and high-order functions for reusable logic. Use local functions to encapsulate helper logic, and mark small, lambda-accepting functions as inline for performance. These practices help you write robust, maintainable code. Always aim for clarity and simplicity in your Kotlin code. Use infix notation where it improves readability, but don't overdo it. Keep your functions small and focused, and use expressive names for parameters and variables. Readable code is easier to maintain and less prone to bugs. You've now learned the essentials of Kotlin's control flow and function features. By mastering these tools, you can write code that's not only efficient, but also easy to read and maintain. Keep practicing with real-world examples and explore more advanced Kotlin features as you grow. Happy coding!